Okay, so good evening,
Good
everyone.
evening, everyone.
Am I
Am I
audible?
audible?
Yes, sir. Yes, sir.
Okay,
Oh,
thank you. So let's wait for
wait
two, three
for 2-3
minutes,
minutes,
then we will
then
get
we will
started.
start.
So basically, in this week, the main focus was on NFA and DFA and how you create an NFA from uh, a regular expression and then how to convert it to DFA. So these all are for lexical analysis part. It is for week 2. Yeah, good evening, Rakesh. So, as taught by Sir in week 2, I will first go through some slides he has shown, then we will go to some problems. So, okay, so I think we should get started now because it's already 7:03. So, in lexical analysis part, what I have told earlier that um we are given an input string and we want to input it to parser for further stages. So lexical analysis is the stage where we actually provide this input. It is basically it works basically as an interface between the compiler's other stages and the user. So we actually provide the uh, input as the stages means from user, and then the lexical analyzer takes that input and recognizes the tokens from here. First it gets the lexemes, then it searches for patterns which is following, then based on that it creates a token for the further stages of this compiler. So next thing is how these things are done in case of lexical analysis. So answer is that we use some finite automation machine which takes some regular expression as input, and based upon that uh, it tries to analyze the uh, input based upon that finite automata, and then just provides an output which is a token. So how it is done? First is um, the there is input, then we provide it to lexical analyzer, then in lexical analyzer there is some automata associated with it. It works to generate the tokens, and the tokens are used in further stages. So that's why we need some knowledge of these finite automata. So there are two kind of finite automata. First is DFA, then there is NFA. In DFA, if you have input, you got some uh, uh, you have an state, you got some input from user, you will go to another state. But in case of NFA, you can land on multiple states. Sorry. So how we take input, we take an we for a time being we take regular expression as an input to the automata, and we create some epsilon automata, epsilon NFA from that regular expressions, and based upon that, we what we do is we actually convert that NFA to DFA, and that actually results in the final automata. So in today's lecture, my main focus will be on this only, that how we will take regular expression, and how we will convert it to NFA, and then some examples on how can we convert that NFA to DFA. Then Sir has told something about parser. So parsers are basically used for uh, checking the grammar. So we will get token, we will use some parser to parse it, and as an input we will get a grammatically acceptable grammar, sorry, input. So first, the week content, what is taught in this week. So first there was an example of NFA to DFA. So in NFA to DFA, how we do this is actually told. So I am just revising it to you. Mm, so so just confirm whether my screen is visible or not. Okay. So anyone please confirm whether my screen is visible or not. Just write on comments. Okay, so no comments. So I think it's visible. Okay, thanks, Anis. So uh, to convert this regular expression to NFA, for PMRF scholars, if I can't comment, you can go to PMRF website. Everything is given there, and also now symposium is done, so you can go through that symposium video, uh, because this lecture is totally based upon, means dedicated to NPTEL only, so I can't discuss that here. Means it's my duty to serve for NPTEL due to PMRF scholarship. Okay, so if there is okay, so if there is an epsilon move, so if we get epsilon as an input, so how we will present it, like we are in this state. After getting epsilon, we will jump to the final state. Okay, so this is actually a final state, this is initial state, and this is some input. Okay, so on getting epsilon or means no input, we are transiting from one state, say q1, to the final state q2. Okay, this is how we show um, regular expression, sorry, NFA, which accepts epsilon, means not any string. And if we consider uh, an NFA which accepts a as an input, only a, so that will be like this. Now if we uh, go for a plus b, means either a or b. Okay, you can write it like a or b also. So how it will be done, we will take an state, then there will be some empty states, then there will be a or b, then epsilon, and the final state. So this is for a or b, either a or b should be present. Now for ab, how we will do, we will take a as input, then there should be b as input, and there will be the final state. But so these are some essentials, and also for a star, means a will be there multiple times. If we write like a4, then a should be repeated 4 times. Okay, so how we will do this, we will take epsilon move, then there will be a, then there will be epsilon, again epsilon, final state, and so what it is telling, we if we get a, we can move multiple times for a, or we can directly without accepting any string, we can go to the final state. Okay, or after getting a, we can go to final state. So this way, means what it will contain, means epsilon a or up to a multiple times. So these are some basic way of representing regular expressions to NFA. Uh, so now, based upon these rules, the NFA is actually made in that slide. Now coming to the weak content again. Okay, so now this is for 1 0, 1 plus 0, and then star, and then 1. Okay, so they have just created this 1 plus 1 or 0, then on epsilon move, this is for your means star move, and then there will be 1. So how we will convert this NFA to DFA, we will we can actually go in two ways. One way I have told in the previous lecture, using transition tables, or you can go in this way also. So we will take epsilon closure of this state means the present state, the start state, and then based upon that epsilon closure we will take an input and search for each of the state we are getting with the uh, that epsilon closure means each of the state in that epsilon closure, and we will append that, we will create a new state, and again we will go to uh, uh, search for new state, how it is taking transitions on each of the input, and then we will get final state, then we will stop. So how we take epsilon closure, just giving you one example of this also. So so this is for epsilon closure. So epsilon closure is actually in which state you can go using epsilon move, means without taking any input, uh, in which states we can go. Okay, so let's consider an example. There is 0, sorry, it is looking more like end state. This state 0, then 1, then 2, then 3, sorry, it's 5, 3, 4. Okay, so this is an epsilon and f given, and what will be the epsilon closure. Okay, so of 0, 1 and 2. Okay, so what we have to do, we have to consider epsilon closure of 0, epsilon closure of 1, and epsilon closure say of this 4. Okay, so epsilon closure are the set of states where you can go without uh, with epsilon move, you can say, or without any input. So can anyone comment? So comment box is open, just write the epsilon closure of 0. I want you all to get interactive in this case. So you have to search for each of the state you can go from 0 with epsilon move, only epsilon move. Okay, just tell this one try is consider this also. Okay, now it is looking more better. Just solve it. Comment box is open. Write in comment what will be epsilon closure of 0. First, for epsilon closure 0, just write which states will be there. Set of states, not only one state, set of states. Like for example, from 0 with epsilon, I can go to 1, then uh, there is no input, there is epsilon move to 2 also. So we can, from 0 with epsilon, we can go to 2 also. So that will also be in this set. Okay. Similarly for 5, 0, 1, 2, then 5, 1, 2, 3, 4, 7. How 4? Let me write it more clearly. States are outside the box. I am writing the states inside the box, okay? So that don't get confused anyway.
Sir,
Yes.
epsilon into sir 0, 1, 1 and 0, 1.
No, no, I will tell. Just you just comment your answers. I will tell in 5 minutes. I am just writing this way. Okay, so it is 0, not it's not a final state. 0, then this 1, 2, 3, 4, 5, 6, then 7. Okay, so let's see. You guys have commented 0, 1, 2, 5, 7. Okay, 1, 2, 3, 4, 7, 0, 1, 2, 5, 1. Uh, presentation is not visible. So okay, 714. It's now visible. Okay, so let's go one by one. So from 0, getting epsilon, first where we will go? We can go to 1, and with this move we can go to 7. That's fine. With 1 epsilon we can go to 1 and 7. Now consider epsilon move is nothing, so 2 epsilon will be also epsilon. Okay, means we haven't got any input. On just empty move we are going to certain state, we are transiting between the states. So now we are at 1 and we are at 7. From 7 we are not going anywhere because there is no outages. From 1 where we can go with epsilon move, that will also be there in epsilon closure of 0, because we will consider that there is no input, means 2 epsilons is also a single epsilon. So from 1 we can go to 2, from 1 we can go to 5. Okay, and one more thing, uh, 0, because it is by default, you can say that we can without getting any input we will be in that state also, so 0 will also be there. Okay, anywhere more we can go, just see. Now we are at 2, we are at 5. From 2 there is no epsilon move outside, and from 5 also there is no epsilon move, so we are done with it. Okay, so what we have got, if we write it serially, 0, 1, 2, 5, 7. Fine. Any doubt? Just write in comment. I think no doubts. So what will the epsilon closure of 1? Just comment it. Not visible screen. Is it problem with anyone else? Because now I have joined with other device also. It is clearly visible. Okay, I am not visible. That is fine. If I am audible, that is fine. The screen should be visible. The screen should be visible to you. So 1, 2, 5. Any other answers? Any other answers for epsilon closure of A? Sorry, 1. Okay. So for epsilon closure of 1, what we will do? We will stand at 1 and we will see where can we go. Okay. So we are at 1 at this stage, and with this, just see for epsilon moves. We can go to 2, we can go to 5, and with the without any silent closure 471. 471? No, no, not like this. From 1 where you can go to on not getting any input. That is the question. Okay. Or you can say epsilon. Epsilon is actually you have some empty string as input. So if you are at 1 and you are not getting any input, so you will be staying at 1 only. That's first thing. Second thing, just stand at 1 and see where are the epsilon moves. Okay, so epsilon move will take you to another states, means it will tell that without any string as input or empty string, taking in empty string as input, you can go to other states. So from 1 uh, on epsilon you can go to this 2, and from here you can go to 5. Okay, 2 and 5. You are now 2 on 2 and 5. Just see whether you can go anywhere with empty string or epsilon when you are on 2 and when you are on 5. So from 2, is there any outage from 2 which is having epsilon move? No. From 5 also there is no epsilon moves. So this is your final output. So this is actually in sequence also. So epsilon move, epsilon closure of 1 will be 1, 2 and 5. Fine. Now coming to the epsilon closure of 4. Just comment what will be. 471. Epsilon 471. You are very near to the very close to the output. Just from 1 you went to 7 and 4. Now stand at 7 and just search for if you are at 4. Very close, Rakesh. Epsilon closure of 4 is 471. 47125. 47125. Yeah, it's looking fine. Epsilon closure of 4. No, no. Epsilon closure of 4 will not be 471. means these will be there. Not to you, Rakesh, you are right. For Ganesh, uh, just go means layer by layer. First stand at 4, see where you can go. Then from 4 you are going to 7 and 1. So now stand at 7 and see from where you can go with epsilon moves. And then from 1 where can you go? Just you will get the answer. Okay. So if you are at 4, you are at 4. So without getting any input or with empty string, first you will be on 4 only. That is one thing. Then from 4 where you are going to which state with epsilon move, we have 7, and from this epsilon move we have 1. So 7 and 1. Now stand at 7, just see if there are any outage having epsilon move. So from 7 you can't go anywhere. Then from 1 where can you go? You can go to this 2 and this 5. That's fine. So 2 and 5. Oh, uh, just a second. My device is getting disconnected due to internet failure. Hello.
Hello.
Am I audible
Am I
now?
audible now?
Okay. So I think my screen is also not visible. Okay. So no. Okay. Uh, so I am explaining it again. First we were at 4. From 4 we saw where we can go with epsilon moves. Okay. So without getting any string we can be there on 4 only. So 4 will be in this epsilon closure. Then with epsilon moves, one epsilon move where we can go to 7, we can go to this 1 with this transition. So we are at 7 and 1. Now stand at 7 and see where can you go with epsilon move. There is no outage, so from 7 we are not going anywhere. Now we can go to 1, just stand at 1 and see where we can go with epsilon moves. So with 2 epsilon moves from 4 we can go to this 2 and 5. So 2 and 5 will be there. Now stand at 5 and 2, just see if there is 3 epsilon move or any epsilon move from 2 to 5. We have earlier seen that there is nothing, so 2 and 5 are the final states. So what we have got is 1 2 5 4 1 2 4 5 and 7. Okay, so in this way we calculate a epsilon move. Now coming to the slides. Okay, so what we will do, we will take the start state, that is A. we will take the epsilon moves, means epsilon closure of this state, and we will consider it as a single state. Okay, so just take A as a start state. From this start state A, on epsilon move, where we can go? We can go to B, we can go to H. Okay, in first move we can go to B and H. With the two epsilon moves, where we can go? From A, B we can go C and D, and from H we can go I. So A, B, C, D, H, I. Now can we go somewhere with three epsilon moves? Means from C to epsilon there is nothing, from D to epsilon there is nothing, and I to epsilon there is nothing. So what we have got? We have got epsilon closure of A as A, B, C, D, H, I. So this will be our first or starting state. Now we have two input symbols 1 and 0. We will take one by one and see from this ABCDHI where we can go with 0 and with 1. Okay, so with 0 where we are going, we will take each of the state in this state, is this composed state you can say, and we will append the outputs. So from ABCDHI where we are going on 0, from A on 0 can we go anywhere? No. From B on 0, there is no 0 move for B. From C there is no on 0 move. From D, where are we going? We are going to F. Okay, so we are going to F with 0 move, and also the epsilon closure of F, that is we can go to from F to G, and from epsilon move from G we can go to A again. Okay, now with A, just take the epsilon closure of A also, that will land us to ABCD HI. Okay, and again if we will go to ABCD HI, so what we will remain with, we went to D, just come to H. Is there any move with 0? No. With I, is there any move with 0? No. So what we have got from ABCDHI, we went to ABCD, means first till ABC there was nothing, then from D you got FG. Okay, we got F, from D to F, and from F to G, and from G to A, and from A we went to BCDHI, taking epsilon closure of all this. So FG ABCDHI will be the next state where we have got from 0 move from this ABCDHI. Okay, now with getting 1 where we will land, just see ABCDHI on 1 where we will go, from A on 1 we are not going anywhere, from B on 1 we are not going anywhere, from C we can go to E. Okay, we went to E. Okay, and from E we can go to G, because we will take epsilon closure of E. So from 1 we will go to G, so G should be there, and from G we can go again to A, so ABCDHI will be there. Instead of a single state, what I want to make comment that we will consider overall state, or we can say we will consider the epsilon closure of the states while transition. Okay, so ABCDHI we went up. Now we went to C. Now for D, on 1 there is nothing, for H on 1 there is nothing, for I on 1 we are going to J, so J will be there. So we can write it like eg abcdhij or ej abcdhi. Nothing problem there is. So from so that's no problem for us. We can write ej gabchi or eg abcdhij. So that is just sequence. Now what I want to tell that this is another state. Now have to we have two another states, and the state with the final state in it, we will consider that final state also. Okay, so j is there in this group, that's why it should also be the final state, as j is the final state here. Okay, that's fine. Now coming to the next part, now we will at we are at fga bcdhi. So from here, where we can go on 0 and on 1. So from f can where can we go on 0? On 0 there is nothing, on g there is nothing, then on a on 0 there is nothing, then on b on 0 there is nothing, c there is nothing, then d we will have uh, transition to f. So f is there already, so we should not mention. Then from f with epsilon closure we can go to g and all. So that will be there in this subset only. And h there is nothing on 0, I there is nothing on 0. So ultimately we have got the states which are already there, and there is no means not any state which is not in this set. So on 0 it will remain in this only. Now on 1, where it can go, on 1 if we will see abcd abd is fine. From c and I we will go to j and e, and that will ultimately result in this state. Okay, so uh, from this state on 1 we will go to the final state. And just you can see for 0, on 0 you can go to this, just see eg ej. So from e on 0 can we go anywhere? No. From j on 0 nothing. From g on 0 no. From a on 0 no. From b on 0 there is no move. From c on 0 there is no move. From d on 0 we will go to f. So f should be there. From f taking its epsilon closure we will go to g, and then a, and then a's epsilon closure will be a b c d h i. So fga a b c d h i will be there. So ultimately that will result in this state. So on 0 it will go to this, and on 1 it will remain in this. So in this way we can create nfa with dfa with the help of nfa. So we can rename these states also, say q1 q2 q3. Oh, this is also fine. So there are some remarks that NFA may be in many states at any time. That is fine, you have seen. On single transition it can go to different states. How many states? If there are n states, the NFA must be in some subset of those n states, and there will be total power n minus 1 finitely many but exponentially many. So DFA can be implemented by 2D table, or we also tell it as transition table in some books, in some differences. Then there will be states and the input symbol, and for every transition state we define transition of state I. On A we will go to some state K. Okay, transition of I A we will go to transition net. So TFL in execution is very efficient. So just like in previous example, what I have told, we can provide them a name. So here they have provided the name S, T, and U. So on S on 0 and 1, on S on 0 goes to T and 1 goes to U. Similarly for T and U, we will just write the symbols or states, and then there is some input and where we will land. So these conversions are actually done with the tools called legs. There are other tools, flex and jflex. Jflex basically works with Java, but DFA can be used. So in practice, let's tool trade-off speed for spacing choice of NFA and DFA representations. So how Lex works? Lex is actually a tool which takes a source program for this lexical analyzer, and the file is actually saved with .l extension. When we provide the source program to the lexical compiler, it provides lex.yy.c. That's actually a C file, and when we provide this .c file to the C compiler, we get a.out. That is the output file, object file, and when we provide input stream to this object file, we get sequence of tokens. Okay, so in this way, a lexical analyzer tool Lex works. So there are three different sections in this Lex program. First is declaration, how we will recognize each of the instruction, then each of the input variables, and then transition rules, then there will be some auxiliary functions. So like this, there are some uh, definitions, then there are some regular expressions or regular definitions, you can say. Transition rules will be there next. So like delimiter, white space, letter, and all, and these are definitions for them. Means less than, equal to, less than, equal to, and all. Then there is function to install lexemes and all. These are told in the lecture side previous years. Uh, in the regular lectures. So what we can conclude is that words of language can be specified using regular expressions, and NFA and DFA can act as acceptors, means we will provide input to them, and regular expression can be converted to NFA and NFA can be converted to DFA. So automated tool Lex can be used to generate lexical analyzer for a language. Okay, so that was for the lexical analyzer part. Now we will do some examples uh, on this, and also see the previous year questions, and then we will take a gist of syntax analysis, which was actually just introduced this week, means in week 2. So let's get started with the examples. Oh, so again there is a problem with the device. Just wait, I'm connecting my device again. So Till now we have covered epsilon closure, NFA, how to create NFA from regular expression, and from NFA how to convert it to DFA with the help of slides only. Uh, so I will take one example for that also. So first I'm going to the previous year questions. So anyone just you are just open to the comment section. Everyone please solve it and give me the answers. Okay, then we will go to solve it. So there are only 4 questions which were unique in previous year. So I am just taking those only. This year questions we are not allowed to take. So question number 1 is, which of the following string is not matched by regular expression? B, A, B or A star, then D and all star. So just comment the answers what you get. I'm just waiting. So there was some problem. Can you comment again what are the answers you have got? Option D, option B. Okay. Uh, no, I am just asking for. It is asking for not matching. Why B and why D? Okay, just see. Let's solve it. No, no, not C again. So just look at it. What we can get from here? How we can get B? If we are considering empty string for this, if it is not providing anything, so it will be BD star, and if we consider it's one occurrence, then we will land it to BD. So A will not be the answer. Okay, not matching. Just see, not matching. Okay, so A is not the answer. Now coming to this one for BABD. So BD is there. If we consider one occurrence of this, so either AB or A, if we are considering AB and one occurrence, so we will land to BABD. So this will be there. Coming to C, BA. So with B, then there is one occurrence of A, two occurrence of A, then there is D. So this is done. Then multiple times it can occur. So from B, then A, two, then D. A is taken two times. So till now we are done. Now B, A, A, B. So from B we are taking A one time and AB one time. B, A, B is done. Then D is done. Then B, A and D. So it can also be considered. Now coming to the last option. BAD, BAB. Till this we were right. Now consider this case BD, BAD. So from here there is a problem. So it is actually taking all the strings. Can anyone comment which is not matched with the regular expression? Because I think all the strings are actually matching. BAB is done, BAB is done, then BD. If we are not considering this as input string, zero occurrence of this, then BD, then uh, BAD, all are acceptable. Maybe cannot come. Oh yes, yes. These two cannot occur. Yes, that's right. So if that will be there, D should be there. Yes. So D is the right option. Thanks, Manju. So 2B can't occur once because there is AB and B. And if you will consider B, so it should come with D here. So that is the point we have to make. So D is the correct option. D will not match this regular expression. Okay, this is very simple one. You can comment at a time and an FA can be in. It is very simple. Just I just want your answers. Yes, many states. A and output of Lex program is available in a file named. Just comment. It is also very theoretic. B. Yes, that is fine. This one. Lex specification. Yes, D. These are theoretical questions. Now coming to some exercise we can do with NFA, DFA and their conversion. Okay, so let's get started with some simple questions. Let's consider we have to create NFAs. First, NFA from regular expressions. Okay, so we have to go to like in previous slide how I have told uh, so just follow these rules. I will just ask number of the number of states we will get You have to just write it. Okay, so first is a plus b star ab. You don't have to optimize, you have to just write number of states when we will go to uh, the solution in following only these rules. Okay, so just write number of states, how many states we will consider, then I will go to the solution. If we will go very traditionally, how many states we will get while creating an FA from this regular expression. I am waiting for just 2 minutes. Just comment how many states you are getting. You don't have to optimize. No, I'm not telling about closures strings. Just number of states. Like uh, we have, if there is epsilon move, there are two states. Okay, so only two states. Okay, so how many states you will get when you will make it using the rules I have provided. Means I want you to just create that automata and just tell how many states you are getting. No. I think I'm not making myself clear. Okay, just see what I am telling. If you will, you are getting this string. You just create the NFA and just tell me number of states. So, what we will get first, we have to accept. We have to provide A as input. So we provided A. Then from A we have to go to A plus B star. How we represent A plus B star? There is some state on epsilon move, we go to an state, then there are two states. So there should be A, there should be B, then there will be epsilon, and there is epsilon. That we do. So, and for AB, how we do? A, then B, then final state. So these are three. We have to concatenate them. Okay, and then we have to go to our answer. So just going one by one. So first I will take A as input. Okay, say this is state 1. From here we have to add this one here. Okay, so from here call epsilon move A and B. We go to these two, Then there are some epsilon moves. Then there is epsilon move. So there was something like from first state to the last state there should be an epsilon move, and from there also. Okay, so we are now up to here. Now we have to take A, we have to take B, and to the final state. I'm not telling to eliminate any state, just write it like we are going very we are doing very basic exercise. Okay, so what we have got is stage 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 states. Okay, so I have got total 11 states while not optimizing anything. Okay, so what we have done, we have taken three things and we have concatenated each of them and got the answer. Okay, you can optimize it also by means eliminating some epsilon moves. That is also fine. Okay, so okay, just try this one. A plus B plus AB. If I tell I want just single final state, then how many states you will get? Use those rules, but the final states will be same. Final state will be only one. Just comment the number of states you will get. For this one. Okay, so this is one thing. 1, 2, 3. No, just NFA and without optimization. You are not optimizing anything. Just there will be means A plus B will provide you one final state. AB will provide you another final state. I am just telling you have to take one only. Final state. Final state should be only one. See, what you are doing is right. You can do it that way also. Can land to 11 also, but okay. There is no specific answer of this, but okay. So we have three actually. We have 2 plus means we have total 3 inputs which we want in parallel. So we will have 3 epsilon moves. Okay, in first we will get A, in second we will provide B, in third we will provide AB. So first there is A, second there is B, then A, then B. Okay, and then it should be accepted. Okay, so on epsilon move we have to accept it. That is one way of doing it. Okay, you can eliminate all the epsilons also, that is also fine. Okay, coming to the next one. So letter or digits. Okay, Just comment for this, how many states you are getting. Previous slide. Okay. Just write it letter, given letter or digit, and then star. Just write number of states you are getting. Till then I am just moving to the slide. Yes, Chandana. Okay. So any answers for this? How many states you are getting? 7. Yes, you can get 7 also. Very reasonable you will go if you will eliminate epsilon moves, then you will go to 7. If you will not eliminate, you can go to 9, 11 and more. Fine. So if you will go like what we have discussed in the previous slides, so there is letter, we have accepted it. Now this is letter or digit, or letter plus digit you can say. So for that there is epsilon move to certain states. Letter, digit, like this. Or yeah, that is also possible. So 1 2 3 4 5 6 7 9, total 9 states I have got. If you are eliminating some states which we can eliminate, you can see that. Okay, next is just try for this 0 plus 1 star 1 0 plus 1. Okay, in DFA you can comment exactly uh, how many states you are getting, but in NFA you can get more. NFA for more states with epsilon moves. So we have to go in very simple way. Just uh, first there is 0 or 1, so for that you have to create the automata for 0 or 1. So epsilon, then there will be some epsilon moves, then there will be 0 and 1, then again there will be epsilon, then there is epsilon, then there is, oh, just a second. Okay, so we are at here. Likewise, so this is for I think I have forgot. Yes, this is for 0 plus 1 star, this is for 1, and this is for 0 plus 1. So everything we have to concatenate. Okay, we have to make the final state non-final, and we have to add the next expression on that. Okay, so I think these examples are too much for this. Now just coming to a question for NFA to TFA. Okay, so if we are doing something for NFA to TFA, the states we will get will be finite if we are taking DFA for it. So I am creating an NFA. You have to just tell me how many states you will get if you will convert it to DFA. Okay, I have covered it in previous lecture also, and also it is also covered in this lecture. Okay, so this is NFA you have provided. You have to convert it to DFA and just tell how many states you will get if you will convert it into DFA. That will be more feasible for you. Okay, number of states in DFA, how much? Just comment it, solve it and comment it using the way it is taught in the lectures and today also. What you have to do, either you take uh, the way taught in this lecture, just create more than one states based upon the transitions, or you go through the transition table. That is also fine. Both way you can do. Just comment number of states you will get when you will no, not two. You are doing something wrong. Not in hurry, just uh, take your time. Okay, I am giving 4 minutes. It's 8:21. Just comment it till 8:25. Till that time I am just revising what we have done. So at first in slides we saw how to convert NFA to DFA. That is one thing. Yes, two final states will be there. Yes, that's fine. Total number of states. Okay. So then we saw how lex works, then how regular expression is converted to NFA and then to DFA. So in today's lecture till now we have covered epsilon closure questions, then there are some NFA questions, now NFA to DFA conversion questions. Okay, 2 minutes more, just try. Okay, if I share a whiteboard, not exactly. Okay, so what you are actually creating, just create it, write it on this Jamboard with help of your mouse or any device you are using. I have commented the board. Uh, if you want, you can use it and create the DFA so that I can see what you are actually creating. Where is the problem? Okay, so it's 8:25. Let me do the question. Actually, we will get four states. How I am telling. Just take one state and with the help of that, just go to the other possible states on each of the transition. So, okay, if you will get some symbol, you will transit the state. So here are two symbols, that is A and B. Just start with the starting state, that is Q0, and just see uh, in which state it is going after getting A and after getting B, and just create a new state with the help of that. So I am starting with Q0. From Q0 where we can go on taking A. Okay, so if we are getting A here, how where we will go? From A we can go to this A and go to it is Q0 and also to Q1. Okay, so Q0 Q1 we will consider it as a different state. Okay, where we are going on getting this A. Okay, one thing is done. Now see where we are going after this B. Q0 on B, where it is going, it is going now nowhere. Okay, so on B there is nothing, we are remaining at Q0 only. Now consider there is this now there is Q0 Q1. Now see where we are going with this Q0 Q1. Again there is, just wait, let me connect my audio device again. Okay, disconnected. Is my screen visible? Can anyone comment? Am I audible? Just comment. Okay. Okay, thanks. Okay, so we are at Q0 Q1. Now from Q0 Q1, where can we go on A and where can we go on B? So on A, Q0 remains, Q0 goes on Q0 and Q1, and B, Q1 goes on this Q1 only. So we will take Nikhil, am I visible now? Think it's now connected. My other device is also connected. Think it's fine now. So from Q0 Q1 on B, Q0 goes to Q1 and Q1 also goes to Q1. So on Q0 Q1 we will take a set of which is consisting all the transition states from Q0 Q1, that is only B. So we are on Q0 Q1 only. Now coming to A, where are we going? From A we are going to from Q0 we are going to Q1 and we are going to Q2 when we are getting A. So we are actually going to Q1 Q2 and also Q0, and it should be final state because it is consisting this final state. Now coming to this state, where are we going on on A and on B? So on A we are going to so on A we are going to Q0, Q1 is going to Q2, and Q2 on A is not going anywhere, and Q0 on A also goes to Q1. So Q0, Q1, Q2. That is for A. For B, where are we going? On B, we are going to from Q0 on B, we are going to Q1. Okay, and then from Q0 on B, we are going to Q1. From Q1 on B, we are going to Q1. From Q2, we are going to Q3. Q2 and Q3. So we are going to Q1, Q2, Q3. No, not Q2. We are going to Q1, Q3. Am I right? On Q0, Q0 on B, where are we going? We are going to Q1, and Q1 on B, we are going to Q1, and Q2 on B, we are going to Q3. So it should also be a final state. Now Q1, Q3. Just see where can we go now. On B. Q1, Q3 on B. We are going to on A first. Okay, Q1 on A goes to Q2. Q3 on A goes to Q2. Q2 is not a final state, but okay. On A, it is going here, and on B, where we are going, Q3, Q1 is on B, it is going to Q1 only, and Q3 on B goes to Q2. So it is going to Q1, Q2. Okay. So on B, it is going to Q1, Q2. Now on Q1, we have to search for Q1 and Q1, Q2 and Q2 also. So these are not actually final states. So Q2, we on B, we can go to Q3. That is a final state. Oh, sorry, Q2 is also a final state now. So these two will also be final states. I think I have written something wrong in this question. These much final states should not be there. Okay, let me check it. Okay, what I am doing is there is any doubt on B. So Q3 on B goes to Q2, and Q2 on B goes to Q3, Q2, and Q3 on B on A also goes to Q2. That is one thing. Then Q1, Q2 on A, Q1 goes to Q2, and Q2 goes to nowhere. So on A and on B, Q1 goes to Q1 only, and Q2 goes to Q3. Q1 and Q3. So on B, we are going to Q1, Q3. So it is like the, yes, there is some confusion created. Mhm. Q0 on A. Let me cross check it. I think I have done a mistake. Q0 on A, it is going to Q0, Q1. Then on B, it is going to Q1 only. Q0 on B. So it is wrong what I have done. Yes. Sorry for that. It should go to on B, it should go to Q1. Uh, okay. I think the problem is from here. I have wrote it wrongly. So from Q1 on A, we can go to Q2, then go to Q2, and on B, from Q1, we will remain at Q1. So actually, this is the right solution, I think. So, okay, what we have done is we have taken the states one by one. So I was in on state Q0. From Q0, we saw where are we going after getting this A and after getting B. So after getting A, we have two states. First is Q0 and there is Q1. Okay, so Q0 is there, Q1 is there. So we will create a new state Q0, Q1, which will result after getting A from state Q0. This is one thing. Now A is covered. Now come to B. When we will get B from Q0, where we will go? We will go to Q1. Okay, there is only one transition having B from Q0, this one. Okay, so this one. Now where we can go from Q0, if we will get B, we will go to Q1 only. Okay, so we went to Q1 on getting B. Now we are having two states. First is Q0 Q1 and Q1. So first go to Q0 Q1. From Q0 Q1, if you will get A, where we will go? From Q0 Q1, if you will get A, we will check for the set having transition from Q0 to A and Q1 to A. So Q0 to A, we will go to Q1 and Q0. Okay, Q0 and Q1, and then from Q1 getting A, we will get to Q2. So that state we have got Q0, Q1, Q2. Now we will consider it as a single state. So this is that state. Okay, and as Q2 is a final state, we will consider a final state, it also a final state. Now we have Q1. So we are done, and for B, Q0, Q1, Q0 on B goes to Q1, and Q1 on B goes to Q1. So this is actually wrong. Q0 on B goes to Q1 and Q1 on B goes to Q1. So finally on B we will go to Q1 only. Now come to Q1. Q1 on A, where it will go? Q1 on A, it will go to Q2 only. So on Q2, Q2 is a final state, and on B, Q1 remains on Q1 only. That is one thing. Now we have state Q0, Q1, Q2. So from Q0, Q1, Q2, where we will go? We will go to from Q0, we will go to on A, we will go to Q1 and Q0. So Q0 and Q1, and from Q1 on A we go to Q2, and from Q2 on A there is no symbol, so that is epsilon. So Q0, Q1, Q2, that is the same state. So we get here only if we will get A. Now take B and go to the state, another state. So we will take B from Q0, Q1, Q2. From Q0 on B we will go to Q1, okay, and Q0, Q1 on B we go to Q1 only, and from Q2 on B we go to Q3. So Q1 and Q3 are two states. Now as Q3 is the final state, so it will be final state, that is the option, and then we will search for this one. So we have remained with Q2 and Q1 Q3. Now Q1 Q3, from getting 1, what we will go, we will go to Q2. From Q1 we will go to Q2, and from Q3 on A we go to Q2 only. So Q2 is the only one in that set, so we will, on A we will go to Q2. Now on getting B, where we will go, from Q1 on B we will remain on Q1, and from Q3 on B we will go to Q2. So we will go to Q1 Q2 in this Q1 Q2. Now we have Q1 Q2 also a final state, because it is having Q2. Now we have Q2 and Q1 Q2. Q2 on B it goes to Q3, and on A it doesn't go anywhere, okay. And for Q1 Q2, for Q1 Q2, Q1 on A goes to Q2, and Q1 Q2 on A goes to nowhere, so that will be Q2 only. And on B, Q1 goes to Q1 only, and Q2 goes to Q3, so Q1 Q3 on B. And for Q3 on A it goes to Q2, and on B it doesn't go anywhere. So we can consider a dead state where it these can go. Sorry, on A also it goes to, on A also it goes to Q2. So it is done, and for, I think I should create a final again. I am erasing it all and I am solving it again, okay. uh, so there is too much hopscotch. Okay, so the question was like Q0 on A, on AB, then Q1 on B, then A, we are going to Q2, then on Q3 we are going, from Q2 we are going on B and AB. Okay, so I'm going step by step. If I get wrong, just comment, okay. So starting with Q0, Q0 on A, where it will go, on A it will go to Q1 and Q0. So we have state Q0 Q1, one state, okay. It is not final as there is no Q2 and Q3 on it. Q0 on B, where it will go, Q0 on B goes to Q1. from here. Okay, now we have two states, q0, q1 and q1. Now for q1, where we will land if we will get a. For q1, if we will get a, we will go to q2, only q2, and q2 is a final state. And q1 on b remains only on q1 from here. That is one thing. Then q0, q1, we have for q0, q1, just see where it goes with a. With a, q0 goes to q0 and q1, and q1 goes to q2. So this will be the another state, q0, q1, q2, and this will be the final state because it is having q2 in it. On a, it goes here. On b, q1 goes to q0 goes to q1, and q1 also goes to q1. So on b, it will go to q1 only. Okay. Now coming to q2, q2 on a doesn't go anywhere. So for it, we can create a die state, dead state. Okay, and on a, q2 goes to, sorry, on a it doesn't go anywhere. On b, it goes to q3. q3 is the final state. Okay, dead state is optional. And then we have q0, q1, q2. And for death state, there is only configuration a or b. It will be on death state only. It will not get accepted. So q3 on a goes to q2, and b also it goes to q2 from here. Now coming to q0, q1, q2, where we will go? q0, q1, q2 on a. If we will get a here, q0 goes to q0, q1 goes to q0 and q1, and q1 goes to q2. So, and q2 doesn't go anywhere with a. So on a it will remain here. On b, where it will go? q0 goes to q1, q1 goes to q1, and q2 goes to q3. So q1, q3 will be the state where it will land after getting b. Now q1, q3 is there. Just see where it goes on a. q1 on a goes to q2, and q3 on a goes to q2. So it will go to q2 only on getting a. And b, q1 goes to q1 and q3 goes to q2. So it will go to q1, q2 on b. Now q1, q2 is there. From q1, q2 on a, where we will go? q1, q2 on a, we will go at q2, and q2 on b. On a goes to nowhere, so we will go to q2 only. Okay, so on a, okay, again connection is lost. Let me reconnect. Okay, connected. So we were here on Q1, Q2. A, we will go to Q2. Now Q1, Q2 on B. Q1 on B goes to Q1 and Q2 on B goes to Q3. So on B it goes to Q3 only. So all states are covered with A and B. So this will be the final one we have got. Actually, I wrote another question, but on writing I uh, wrote some wrong symbols. I mean, misplaced the symbols A B with A. So that's why it goes. Um, it went so long. It was very a small question, but it was changed. So it is now a very long question. So if you haven't got, you just the slide will be uploaded. Just go through it, and if you are not getting, just ask me in next session. If there is anything wrong in this solution, you can also comment uh, today also and in next session also, because it was not the question I had taken. It was something like there was a B. Previous week's slides I uploaded. I uploaded it. Uh, Let me check. Previous week's slide is uploaded. It is there. Lecture and slide both are available. Just check it again. Okay, so uh, I don't, I can't comment for last date of exam registration. We can see only week one problem solving session video. How is it possible if I am loading it? Just let me cross check it. Oh, it's visible. You just cross check it again. It is there. If I share my window, just a second. So all is done from my side today. What I wanted to talk about. So that is actually done. So let me check for you what it is showing actually. Mm, Let me see. Okay, is my screen visible? Just comment. Is my screen visible? Okay, so this is the course page and problem solving session. If I go to this, I have to click on this. Let's see, it is there. This is week 1, then week 2. And if you are telling about the PPT, this is also there, week 1 and week 2. All things are there. Just cross check and with a stable connection. I think there is problem with the connection. Okay, so it's all from my side today. We will meet next week. So in today's lecture, what my motto was to cover some of the questions based upon TFA and NFA. So that I have covered. And also if there is some confusion, because last question what I solved was the question was different what I was solved in my copy. So there may be some errors, so you can comment on next session and you can try with your own, and if there is some errors in that solution, then you can just comment in next week session. I will check it again, and the lectures will be uploaded within 2 or 3 minutes, and the video after 2-3 hours, because it takes time to get compiled. So I think what I have told today, it was very simple, except the last question. There was some confusion. That was not tough, but there was some confusion. So uh, I am just uploading the slides, and also if there is any doubt regarding week lectures, you can comment on discussion forum. I will consider that. I will check that and get back to you. And also in problem solving session, if you want something from me to solve, you just write on chat box. I will try. But that should be for that week only, or the previous week. Okay. So thank you all. Uh, just finishing this lecture. Thank you. We'll meet next week. Thank you. Thank you.